going to now work on factoring x squared plus bx plus c, which is a trinomial, because it has three terms. Okay, so what we're going to be looking at is, for example, factoring something like this: x squared plus 11x plus 18. Now, the key to factoring this is looking at the last term and the middle term. So this term and this term, especially the number. Okay, so what you want to look at and ask yourself, what I like to do is create an x, and I put this number at the top, and the middle number at the bottom. And I ask myself, what two numbers both multiply to 18? That's going to be these two middle numbers. Which two numbers are going to multiply to 18 and also add to 11 at the same time? Okay. Now, if you think about it, it's a little bit of a puzzle, but if you think about it, those two numbers are 9 and 2. Okay, 9 times 2 is 18, but 9 plus 2 is also 11. Okay, so you want these two numbers to be simultaneous in doing that. So, what that means is that this polynomial is going to factor as such. Okay, it's going to factor as x plus 9. Now it's plus because the 9 is positive, and x plus 2, and that's because the 2 is positive. Okay, and to double check ourselves, we can multiply this out. Now you can use the area model, you can use a distributive property. For the purposes of this video, I'm going to keep it very straightforward, and I'm going to use the distributive property. So x times x is x squared. Okay, x times 2 is positive 2x. Okay, and then 9 times x is positive 9x. And then 9 times 2 is positive 18. And then combining like terms, the 2x and the 9x, we get x squared plus 11x plus 18. So it's equivalent to our beginning. So this is indeed the factors. Remember, factors are two expressions, values, numbers, whatever, that multiply to a product. Okay? So I'm going to give you guys 3 to try, and then I will display the answers. Okay, so those 3 that I want you to try are to factor the trinomial x squared plus 3x plus 2. The second one is a squared plus 7a plus 10. And then finally, I want you to do t squared plus 9t plus 14. Okay, so go ahead and pause the video and try these out. Okay, and there is the results. Okay, let's move to a couple more examples. Okay, so here's another example. We want to factor n squared minus 6n plus 8. So this one's a little different because now we have a minus in the middle, but again, just think of it, you focus on the last number and the middle number, including now the sign in this one. So you're going to include negative 6. And again, you're going to create a little bit of an x on the side to kind of think of, or create a puzzle out of this. The top number goes here. Okay, 8 and negative 6. And you want to ask yourself, what two numbers multiply to 6 and add to negative 6? Now, if you can't think of it, what I like to do is to take the product one. Okay, again, these two have to multiply here and also have to add here. Okay, and I like to list all the possible factors. You have 1 and 8. you have 2 and 4. Now, that's not the only ones because none of these add to negative 6. You have to also consider negative 1 and negative 8, and negative 2 and negative 4, because a negative times a negative is a positive number. So, in this case, negative 2 and negative 4 work. Okay, because negative 2 times negative 4 is positive 8. Negative 2 plus negative 4 is negative 6. So now when you factor this, the factors are, make sure you maintain the same variable, n minus 2 times n minus 4. Okay, and that's because these ones are negative. Okay. Here's another example. Okay, let's say we want to factor y squared plus 2y minus 15. Okay, so again, now the negative is at the last term, but again, the rules don't change here. Okay, you're looking at this number with its sign, and you're looking at this number and its sign. Okay, so I like to create the x, put negative 15 here, and then positive 2 on the bottom. We want to ask ourselves what two numbers multiply to negative 15, but also add to positive 2. Okay, so again, if you can't think of any off the top of your head, again, list out the product number. Okay, so list out negative 15 and all its factors. So you have 1 and negative 15. You have 3 and negative 5. Okay, that's obviously not the only ones. You have to flip the negatives. So negative 1 times positive 15 and negative 3 times positive 5. So when you look at all these options, only one adds to positive 2, and that's this one. So negative 3 and positive 5. So now, again, keeping the variables consistent, you can't change. It's going to be y minus 3, because 3 is negative, times y plus 5. And that's your answer. Okay, so again, I'm going to give you a couple to try on your own, and then I'll post the answers after a few seconds. So we have x squared minus, so we want to factor each of these, minus 4x plus 3. We have t squared minus 8t plus 12. We have m squared plus m minus 20. And then w squared plus 6w minus 16. Okay, so I will pause the video, give you guys an opportunity to try these. And there is the results. Okay, so with that being said, there's one more example that I want to go through. And it's a special case. It's called the difference of two squares, difference of two perfect squares. Okay, this is a very important one because you use it a lot in Algebra 2. Okay, so it's the name applies what it is that we're doing. Okay, we're taking a difference of two perfect squares. So for example, if we have y squared minus 16. As you'll notice is that the middle term of the trinomial is not there. So remember, our typical trinomial is like this. Ax squared plus bx plus c. And remember that we found, okay, two numbers that multiply to the last one and add to the middle one. Here, there is no middle term. There's no term with just a variable with exponent of 1 in the middle. There is none. So basically, it's like what two numbers multiply to this last term but add to 0. Now, you can think of it that way, or you can think of this as literally a difference of two squares. For example, this here is a square, the shape itself, and you have a length of y times a length of y minus, and then this is also a square. See, we have a square of an area of 16, right? Because this was an area of y squared. This is 4 times 4. Okay, it's a difference of two squares. So this is always going to factor like this. The variable itself, y, okay, minus 4, and then the opposite. Because remember, they have to add to 0. So y plus 4. So it's like taking the side lengths of the square itself. Okay, so y minus 4 and then y plus 4. Okay, and that's because these two multiply to negative 16, but add to 0. Okay, which is that middle term that we're missing. So let's do another example. So let's say we have 25m squared minus 36. So again, this is another difference of two squares. A much more complicated case, but the same thing. If you look at it here, this square with an area of 25m squared has the lengths of 5m. Okay, because 5 times 5 is 25, and m times m is m squared. Okay, minus this square, which again in this case is an area of 36, but that is quite simple. It's just 6 times 6. So this is going to factor very similar to what we just did. Whoops. Don't pay attention to that. 5m minus 6 and then 5m plus 6. Okay. All right. So let's give you one to try, and then pause it, try it out, and then unpause it, and then see if you got the right answer. Okay, so let's do, we want to factor the polynomial 4y squared, okay, minus 64. Okay, so go ahead and pause the video. And there it is. And that about wraps it up.